All right, so we're going to start with evaluating expressions. We have mp plus p squared, m equals 5, and p equals 4. So what we're going to do is replace the 5 and the 4 in the spots where m and p are, and then solve it just like we would in order of operations problem. So we're going to say 5 for m times p, which is 4, plus p, which is also still 4, squared. You're just going to solve this PEMDAS style. So we'll do 4 squared, which will be 4 times 4, which is 16. And then we'll go ahead and do 5 times 4, which will be 20. 20 plus 16 will end up giving us 36. All right, so we have another problem where we have x times 5 minus y. So x equals 9 and y equals -3. So it's really important that we realize that the number is not just a regular 3, it's also a -3. So we'll say 9 times 5 minus, and that's a -3, so I'm going to write it as 5 minus -3, which if we know our keep, change rules, we'll keep, change, and get 5 plus +3. So 5 plus 3 we're going to go ahead and complete first because it's inside of our parentheses. So we'll have 5 plus 3, which will be 8. 9 still on the outside. And then since they are right next to each other with parentheses, we know that's multiplication. So we're going to say equals 72. Okay, for our next one, we have y plus y minus x divided by 3 plus 3. X is 12 and y is -3. So we're going to replace -3 in place of both of these y's and say -3 plus -3. And then we're going to bring down that minus in parentheses 12 divided by 3 plus 3. So again, we're going to solve this just like we do PEMDAS style. So we'll start with 12 divided by 3, which we get 4, plus our 3. They are still in parentheses. We're going to complete that first, giving us 7 here. This minus sign is just going to go ahead and come right down, and we'll go ahead and solve our -3 plus our -3. Since these are same signs, we're going to add and keep the sign the same. So we have -6 minus 7. Keep, change, to give us -13. So these are all expressions that can only be simplified, so we won't have a solid answer at the end. So we're going to look for things that can go together. So at this first one, we have k that can go with 12k. The reason why they can go together is because they both have a k. So this is just a 1k plus our 12k. So that's going to end up giving us 13k. Then we have a -4, also known as -4, and a +9. So if I do -4 plus 9, that's only going to give me a +5. So my answer is 13k plus 5. With our next one, we have 2m squared minus 7m plus 10 plus 5m squared plus 7m. So our 2m squared is going to be paired up with the positive 5m squared. So when I combine 2 and 5, I'm going to get 7m squared. I do not have to use the exponent. The next one, we have -7m with positive 7m. So if I do -7 plus 7, I end up getting 0m. And when you have 0m, it just goes away. And then lastly, we have a plus 10. The 10 doesn't really have anybody else to go with, so we're just going to write it as plus 10. All right, our third one, we have 5 in parentheses x minus 9. And since x minus 9 cannot go together, we're going to use the distributive property. We're going to use the distributive property to get rid of we're going to use the distributive property to eliminate the parentheses. So we'll do 5 times x, which is 5x, and then 5 times a -9 to give us -45. And at that point, there's really nothing else for us to do because that's the smallest it's going to get. Over here, we have negative 10 times 4a minus 2 plus 11. So we're going to distribute and say negative 10 times positive 4a to give us negative 40a, and then negative 10 times negative 2 to give us positive 20. We'll go ahead and bring down our plus 11. So at this point, we have to look and say, okay, well, how many other things can be combined together? So 20 and 11, since they're both constant terms, they don't have any variables, they can be combined together. So the negative 40a is going to just stay the same, and we're going to add it to 31. And that is going to be our final answer, because this is as small as we can get it, so it's going to be the simplified version. All right, so our next part is going to be the polynomials. So we're going to still combine like terms, but sometimes we'll have to do something special. So when you have an addition polynomial, there's really nothing special you need to do. It's just still going to be a plus problem. So we're just going to combine like terms across like we normally would. So we'll combine 3x with this 2x to give us 5x. Then we'll combine 4y with this minus y. So that's like saying 4 minus 1, which will give us a plus 3y. Lastly, we have a negative 9, and we're going to add it to a plus 6. So negative 9 plus 6 is going to give us negative 3, or minus 3. At this point, there's nothing else to combine, so we are all done. For our next one, we have it a little bit different. We have a minus in between. So that minus is going to basically make all of this be taken away. So we're going to put a 1 there because there's always a 1 on the outside of every parenthesis. And we're going to distribute that negative 1. By saying negative 1 times a positive 5, that's going to give us a negative 5. By saying negative 1 times a negative 9, it's going to give us a positive 9. So the signs have now changed what they were originally in the inside of the parentheses. Everything else is just going to go ahead and just come down just like it normally would. No changes to those at all. So the next thing we want to do is go ahead and do combine like terms. So we have our 2b, which 2b doesn't have anything else to combine with, so it's going to just remain 2b. We have a plus 7. We have a plus 7 and a plus 9. So we'll do 7 plus 9 to give us plus 16. And then our last one, we have negative 5a minus 5a. Now I know it looks like they might cancel out, but this is a negative 5 taking away 5 more. So if I already owed my friend $5 and I borrowed $5 more, well, my debt is not 0. And now I owe them $10. So it's going to be a negative 10a. All right, so now that we have those numbers, there's really nothing else left for us to do because we have a b, a constant term, and an a. So there's really no other terms to put here. All right, and our last section is going to be exponent rules. So with exponents, we have specific rules when we're simplifying them. So we're not actually going to be multiplying each exponent out like we normally would if we were trying to evaluate or solve. So we're going to do our first one here. So we have 2 squared times 2 to the 4th power. So in longhand, this looks like 2 times 2 times 2 times 2 times 2 times 2. So if these are all already multiplying together, that's going to give us 2 to the 6th power because I have 6 2's. Or an easier way of doing this is just saying 2 to the 2 plus 4, which would be 2 to the 6th. If you're dividing exponents, it's going to be the opposite of multiplying them. With multiplying, we just add our exponents together. With division, it's going to be subtraction. And in longhand, which I didn't leave myself enough room, I'm going to go ahead and bring down here. If I have 6 times 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 6, let's see, 2, 4, 6, 8, oh man, I was 1 off, times 6, so 10 6s on the top. And 6 times 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 6, 8 on the bottom. If I wanted to divide these, I would cancel out all of these 6's, and I'm left with 2 of them. So this would just be 6 squared. Okay? And an easier way of doing that is just saying 6 to the 10 minus 8, which would be 6 to the second power. So either way I do this, I still get the same answer. The next one we have is a power of a power. So we have 3 squared to the 4th power. So what we're going to do here is say, okay, if I have 3 times 3 in parentheses, and I have to do that 4 times, that would be 3 times 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 3. Okay? So if I look about how many 3's I have 8 of them. So I could say 3 to the 8th power. Or the easier way of doing this is just saying 3 to the 2 times 4, which is 3 to the 8th power. Anytime we have anything to the 0 power, no matter what the number is, your answer is always just 1. Okay? Anything to the 0 power is 1. However, if I had 11 to the 1st power, that would be 11, because I have 1 11, okay? Unlike here, 11 to the 0, 1. 4 to the negative 3. To make a negative number positive, negative exponent positive, we need to flip it over, the reciprocal of that number, and put the exponent on the bottom below the fraction line. So every whole number is over 1. So we're going to flip this over and make this 1/4. Now, by flipping it, I make this negative 3 a positive 3. So it'll be 1/4 to the 3rd power. And that's it.